Ma'am, you're the host now.
जी सर, थैंक यू। You have to say okay to it because it's not on my end. Thank you. All right. Today's lecture is going to be about oceanography. We have finished, this is the last of the physical geography topics. After that, we should ideally begin with Indian geography. So this will be the last of the physical geography topics that we have. Oceanography, we've already done with universe and earth. We've done with geomorphology, the rocks and weathering, erosion, all sorts of landforms included. And then we went on to did climatology, and now we are going to do oceanography. Oceanography is a very simple topic. We are trying to basically see all the major and minor relief features of the ocean floor. So we are going to, can you hear me? Sunai Dera? Sunai Dera. Okay. We are going to study about the major and minor relief features in the ocean, and then generally check out the temperature and salinity of the ocean water. There is a standard way of doing that. We'll look at that, and then after that, we are going to look at the ocean currents and the tides. Okay. The most questions asked are about ocean currents. We've already discussed this, right? Just like in climatology, when we asked about what kind of local winds flow, whether they are warm winds or cold winds, and in which area, in which region they flow. Okay, so here ocean currents will be mostly about whether they are warm ocean currents, cold ocean currents, or usually in which region or in which sea will they be formed. Okay, that's the general question being asked. Major and minor relief features usually warrant maybe a couple of questions occasionally. Okay, very rarely will they be asking you these questions, but they do ask you these questions sometimes. Especially like what is the difference between sea mounts and geos or something like that. Okay, so that is what we'll be looking at. Tides is another important topic. We'll be asked questions based on that. Okay, these are the general topics on which questions will be asked. Okay, we begin here. Before we start with the before we start with the oceans, these are the 5 major oceans in the world based on their size. So the satta for it is FESA. First is Pacific, then is Atlantic, then is Indian, then the Southern Ocean or the Antarctic Ocean, and lastly the Arctic Ocean. Okay, that is the size of the oceans. All right. And then now we discuss where the water on all the Earth's surface is locked. Okay, so most of the water is locked in oceans. 97.25% of the water is locked in oceans. Okay, 2.5% is locked in ice caps and glaciers, and groundwater is around 0.68%. Lakes are around 0.01%. Okay, internet चला गया आपका. I'll wait until you're back. Okay. Uh, Groundwater is around 0.68%, followed by lakes, which is 0.01%. And then soil moisture is even lesser, so 0.05%. Atmosphere is even lesser, 0.01%. And streams and rivers are like 0.0001%. Okay. So, and lastly, biosphere. So, even if we feel that the streams and rivers and lakes are the most easily visible water surface or water on the Earth's surface, it is basically oceans where all the water is locked. Okay. Because oceans are very deep also and huge also. So, you don't know how much, you can't fathom how much water there is. Okay, okay. Now, this is the proper relief of the ocean floor. When we say relief of the ocean floor, we are looking at all the major and minor landforms on the ocean floor. Okay, this is generally how the ocean floor begins. This is the continent on this particular data set. Yeah, on this side, the one that you can see over here is the continent. Okay, And this continent usually, when part of the continent goes underneath the water, it is called as the continental shelf. Okay, so it is usually a very shallow portion. It's a major landform, but it's a shallow portion. Okay, so this is the continental shelf. After that, the next landform that you encounter is the continental slope. Okay, there is a proper slope over here where it connects the continental shelf to the deep ocean basin. Okay, so the deep ocean floor. So this is what is happening. This is the continental slope which connects the continental shelf with the ocean floor. Okay, and this is the ocean floor. So on this ocean floor, you might find trenches, canyons, stuff like that. You will find them in the slopes also, but this is essentially what you will find. And then lastly, apart from this, you can see these volcanic islands. If they are above the surface of the water, we call them volcanic island. Or if they still manage to come above the surface of the water, we might even call them sea mounts. Okay. If they are flat topped and they lie beneath the ocean surface, beneath the ocean water, then we call them geos. All right. So we are looking at that. This is the mid-oceanic ridge. This is another important thing. We've already seen that as the mid-Atlantic ridge. Okay. So when we have already seen that when what happens is that these two part, okay, we say those two plates are parting away. If they're moving away from each other, then lava upwelling, there is pure lava upwelling from this side, and that will give rise to these small mountain ranges that are formed over here. Okay, so that is the mid-oceanic ridge that you're talking about. All right, okay, and then other landforms. These are the landforms that you're essentially trying to see. You have already seen the continental shelf and the slope, deep sea plains, oceanic trenches and deeps. Apart from that, the minor relief features would be mid-oceanic ridges, seamounts, geos, and atolls. Okay, let's try to see. The characteristics of each of these now. Okay, the very first is going to be the continental shelf. Okay, that's a huge one. It is also one of the most important ones because it's economically very important for us, as far as human beings are concerned. Okay. So it is like we discussed, it's an extension of the continent under the shallow sea. Okay, लग रहा है ना यहाँ पे कि वो continent extend कर गया था नीचे की तरफ. This is an extension of the continent. So clearly it will be a little shallow over there. Okay, because उसका height अभी भी है continent के जितना ही, थोड़ा सा नीचे कम होगा लेकिन है, height तो है उसको. Okay, तो clearly वो थोड़ा सा shallow sea के अंदर चला जाता है. The average slope of the land is 1% or even less. Okay. Now, ये जो continental shelf का width होता है, that keeps varying from 0 kilometers to 1500 kilometers. Okay, so 1500 kilometers is the Arctic part. यहाँ पर ये वाला जो पोर्शन है ना, यहाँ पर कॉन्टिनेंटल शेल्फ बहुत वाइड है. ओके, दिस आर्कटिक ओशन में जो रशिया के ऊपर वाला जो कॉन्टिनेंटल शेल्फ है, दैट इज सपोज टू बी वेरी वाइड. ओके, एज अ जनरल रूल, यूजुअली अगर आपको कोस्टल लाइंस पे, मतलब कोस्ट के कोस्ट पे अगर आपको हाई माउंटेन्स या क्लिफी फीचर्स मिले ना, तो कॉन्टिनेंटल शेल्फ पतला होता है, नैरो होता है. ओके, एंड अगर यूजुअली फ्लैट होगा कॉन्टिनेंट्स का कोस्ट, यूजुअली अगर कोस्ट थोड़े फ्लैट होंगे, वाइड होंगे, तो यूजुअली कॉन्टिनेंटल शेल्फ्स भी वाइड होते हैं. ओके, दैट इज द जनरल रूल. ऐसा नहीं है, देयर विल बी एक्सेप्शंस टू द रूल्स, बट क्लियरली दिस इज द जनरल रूल. ओके, तो डेप्थ कितना होता है उसका? इट कैन बी एनीवेयर बिटवीन 1 सेकेंड, इट कैन बी एनीवेयर बिटवीन 30 to 600 मीटर्स. सो 6 किलोमीटर से नीचे नहीं, लेकिन यूजुअली 100 to 100 मीटर्स तक का मैक्सिमम डेप्थ होता है. That is what we are going. Okay, so we are saying कि average width कुछ 80 kilometers होगा and depth is somewhere around 30 to 600 meters. Okay, so we are saying कि generally ये जो continental shelves होते हैं, they are covered by, अभी clearly there will be rivers that will come over here. Okay, and वो वहाँ पे अच्छा खासा ये बना लेते हैं, sediments वगैरह spread out कर देते हैं rivers अपने. Glaciers, wind, sea, हर कोई आएगा. Sea भी वहाँ पे जाता है ना. Sea is also responsible for all sorts of depositional work over there. तो सी भी अपना डिपॉजिट वहां पे स्प्रेड कर देता है. ओके, तो ये वाली जो ये सब सेडिमेंट्स की वजह से ये वाला जो पार्ट होता है कॉन्टिनेंटल शेल्फ का, दैट्स कंसिडर्ड वेरी इंपॉर्टेंट फॉर फॉसिल फ्यूल्स. वहां पे वो भरे भरे रह जाते हैं, सेडिमेंट्री रॉक्स बन जाते हैं. अगर बायोलॉजिकल रिमेन्स होंगे एनिमल्स के या मरीन ऑर्गेनिजम्स या प्लांट्स के रिमेन्स होंगे, तो वहां पे अपने आप ये बन जाता है, फॉसिल फ्यूल्स बन जाते हैं. एंड ये फॉसिल फ्यूल्स हमारे लिए इंपॉर्टेंट होते हैं. हम इंडिया में ही खुद इस पूरे रीजन में ये फॉसिल फ्यूल्स ढूंढते फिरते हैं. ये जहां जहां ये रिवर बेसिन है ना, तो गोदावरी, कृष्णा, वहां पर रिमेंबर बड़े बड़े ब्लॉक्स गवर्नमेंट अलॉट कर देता है, वहां से हम नेचुरल गैस एंड कोल नहीं, नेचुरल गैस एंड पेट्रोलियम एक्सट्रैक्ट करते हैं. सो
क्या काम आएगा जब काम से भाग जाऊंगा.
यार, पीपल कैन यू प्लीज कीप योरसेल्फ म्यूटेड? One second.
यहाँ पहुंच जाएंगे 2 घंटे में, खाली मेल पहुंचेंगे. अच्छा.
Who is Mohammed Basil and who is this person named N? Can you please keep yourselves muted? You're not classroom people. I can mute this person. Who is this person by the name N? If you can't mute yourself, I'm going to have to remove you from the meeting. And I hope this is very clear to you because I cannot allow any disruptions while I'm talking. Unless you have a question to ask. And if you have a question to ask, you'll have to raise your hand and ask for a permission before you ask the question. You can't simply start talking on the mic as and how you will. ओके हियर वी आर सो वी आर सेइंग कि ये जो पूरा है महानदी का डेल्टा एरिया या फिर गोदावरी का कृष्णा का कावेरी का यहाँ पर आपको ये सारे फॉसिल फ्यूल्स मिलते हैं बिकॉज वी हैव अ वाइड कॉन्टिनेंटल शेल्फ ऑन द ईस्टर्न साइड ओके वो कॉन्टिनेंटल शेल्फ थोड़ा सा वाइड है वहाँ पे सो क्लियरली दैट कैन हैपन ओवर देयर the next thing that we are considering is कि so this is the first very important economic importance of this कि continental shelves पे fossil fuels मिल जाते हैं ओके दूसरी चीज if the continental shelf is shallow and wide अगर वो shallow and wide होगा तो अगर वो shallow होगा तो क्लियरली वहां पे सनलाइट पेनिट्रेट कर जाएगा अंदर फोटिक जोन के अंदर है ना वो क्लियरली तो द सनलाइट कैन पेनिट्रेट अगर सनलाइट वहां पे जाता है तो क्लियरली नीचे का जो छोटा छोटा वो प्लांट वाला प्लांटम्स होगा तो वो बहुत बड़ी हाँ बहुत क्वांटिटी में बढ़ जाएंगे वहां पे ओके बिकॉज देयर विल बी अबंडेंस ऑफ प्लैंटन इफ देयर इज प्लैंटन देन क्लियरली उसको खाने के लिए छोटे फिश आएंगे छोटे फिश को खाने के लिए बड़े फिश आएंगे एंड दैट इज हाउ दैट एंटायर रीजन बिकम्स अ वेरी रिच फिशिंग ग्राउंड ओके सो यूजुअली वर्ल्ड के जितने भी लार्जेस्ट एंड रिचेस्ट फिशिंग ग्राउंड्स होते हैं वो यूजुअली वहां मिलते हैं आपको जहां पर यू हैव अ गुड नाइस विड्थ ऑफ कॉन्टिनेंटल शेल्स सो कॉन्टिनेंटल शेल्स अगर वाइड होंगे शैलो होंगे तो यूजुअली वहां पे रिच फिशिंग ग्राउंड्स भी बन जाते हैं फेमस एग्जांपल्स बीइंग ग्रैंड बैंक्स ऑफ न्यूफाउंडलैंड नॉर्थ सी में डॉगर बैंक है एंड एक सुंडा शेल्फ है यहाँ पे let's try to see this is what we are saying when we are talking about ये वाला जो part है that is the grand banks okay of Newfoundland ये वाला जो island है उसको Newfoundland बुलाते हैं and this place is called as grand banks okay we earlier in this we had also studied कि जब हम एग्जाम्स के लिए पेपर्स डिस्कस कर रहे थे तो मैंने आपसे कहा था कि यहाँ से गल्फ स्ट्रीम आती है ऊपर से लैब्राडोर करंट आता है मिक्सिंग होता है वार्म एंड कोल्ड करंट्स का एंड दैट कोल्ड करंट इज आल्सो रिस्पांसिबल फॉर ब्रिंगिंग मोर न्यूट्रिएंट्स व्हिच आर beneficial to the plankton silhouette okay so this is grand banks ये यहाँ पे doggers bank है okay this is the dogger bank so this is in north sea तो ये यूके के पास वाला रीजन जो है तो यहाँ पर भी बहुत अच्छा वाइड कॉन्टिनेंटल शेल्फ है एंड तीसरी चीज आपको यहाँ मिल जाती है ये वाले रीजन में यू आर टॉकिंग ऑफ दिस रीजन ओके ये वाला इतना पास में नहीं जाना है राइट में नहीं जाना है यू हैव टू गो ओवर हियर दिस इज द रीजन ये सुंडा शेल्फ वाला जो रीजन है ना दिस इज दैट रीजन ओके तो वो वहां पे सुंडा स्ट्रेट्स है ना तो वी आर सेइंग कि ये जो पूरा रीजन है दैट हैज अ वेरी वाइड कॉन्टिनेंटल शेल्फ ओके दैट एंटायर रीजन हैज अ गुड वाइड कॉन्टिनेंटल शेल्फ तो ये सब कुछ बहुत फेमस है फॉर फिशिंग ग्राउंड्स ये सारे रीजन फिशिंग ग्राउंड्स के लिए बहुत फेमस है ओके ठीक है एंड लास्टली वो जो लिमिटेड डेप्थ होता है एंड जेंटल स्लोप होता है नाउ अ डिसएडवांटेज विद दिस केस ओके बिकॉज देयर इज अ लिमिटेड डेप्थ एंड अ जेंटल स्लोप उसकी वजह से हाइट इंक्रीज हो जाती है टाइड्स की ओके तो इसका मतलब क्या होता है क्लियरली अभी वहां पे वाटर शैलो होंगे शैलो इन द कॉन्टिनेंटल शेल्फ पानी थोड़ा सा शैलो हो जाएगा ओके बहुत ज्यादा शैलो पानी में आप बहुत बड़ा शिप नहीं डाल सकते यू कैन नॉट बिकॉज वो आर्किमिडीज प्रिंसिपल के हिसाब से वो उतना पानी डिस्प्लेस करेगा एंड वो क्लियरली नीचे लग जाएगा एंड वो आगे मूव नहीं कर सकता है सो क्लियरली अगर आपको बड़े शिप्स को कॉन्टिनेंटल शेल्फ्स के पार लाना है तो यू विल हैव टू प्रोवाइड मोर वाटर तो ये सिर्फ हाई टाइड्स में आ सकते हैं तो शिप्स को बहुत केयरफुली टाइम करना पड़ता है अंदर आने के लिए कि हाई टाइड में ही अंदर आ सकते हैं तो एंड हाई टाइड में ही निकल सकते हैं वरना वो अटक जाएंगे फंस जाएंगे वही कॉन्टिनेंटल शेल्फ पे तो दैट कैन बी गुड फॉर शिपिंग राइट सो क्लियरली यू हैव टू टाइम इट दैट वे लेकिन फिर भी आपको बड़े सारे मेजर पोर्ट्स मिलेंगे वर्ल्ड के विच आर बिल्ट ओवर हियर साउथहैम्पटन लंदन दोनों एंड ये सारे यूरोप के पोर्ट्स हैं हैम्बर्ग रॉटरडैम हांगकांग सिंगापुर अपने पास वाले. ओके, सो क्लियरली दीज आर ऑल्सो डेवलप्ड ऑन वाइड कॉन्टिनेंटल शेल्फ्स. आइडियली एस्चुराइन पोर्ट्स जो होते हैं वो बहुत अच्छे माने जाते हैं, जहां पर रिवर माउथ मीट्स अंडरनीथ द सी. तो वो पोर्ट्स यूजुअली अच्छे माने जाते हैं. बट अब ये सारे इकोनॉमिक प्लेसेस है, ट्रेडिशनली वेल डेवलप्ड है एज इकोनॉमिक सेंटर्स एंड ट्रेडिंग टाउन्स एंड स्टफ. सो दैट इज वाई वहां पर बिजनेस फ्लरिश कर गया. ओके, सो वी आर जस्ट मैनेज्ड अराउंड इट. ऐसा नहीं है कि हम वहां पे पोर्ट्स बनाते नहीं है. ओके, नेक्स्ट चीज जो होती है, सो प्लीज रिमेंबर कॉन्टिनेंटल शेल्फ के दो फायदे हैं हमारे पास. वन, फर्स्ट ऑफ ऑल कि वो रिच फिशिंग ग्राउंड्स बनाते हैं बिकॉज सनलाइट पेनिट्रेट्स, प्लैंकटन बढ़ जाता है. एंड दूसरा कि वहां पे फॉसिल फ्यूल्स मिलते हैं. ये उससे दो मेजर इकोनॉमिक फायदे. एंड तीसरा, द थर्ड पॉइंट इज गोइंग टू बी अ प्रॉब्लम बिकॉज शिप्स विल बी हिंडर्ड, द मूवमेंट ऑफ शिप्स इज हिंडर्ड अनलेस एंड अंटिल यू हैव अ हाई टाइड. ओके, ठीक है. नेक्स्ट वाला जो है मेजर फीचर हमारा, दैट इज गोइंग टू बी अ कॉन्टिनेंटल स्लोप. ओके, कॉन्टिनेंटल स्लोप ये वाला होता है जो कनेक्ट करता है कॉन्टिनेंटल शेल्फ को विद द एबेसिल प्लेन्स और डीप सी प्लेन्स. ओके, उसके साथ कनेक्ट करेगा. क्लियरली बहुत लंबा फीचर है ना, इट इज लॉन्ग इनफ. सो वी आर सेइंग यहाँ का ग्रेडियंट या स्लोप जो होता है दैट इज समवेयर अराउंड 2 to 5 डिग्रीज. ओके, एंड डेप्थ जो होती है दैट कैन बी एनीवेयर फ्रॉम 200 मीटर्स टू 3000 मीटर्स. बहुत लंबा जा सकता है वो. ओके, यहाँ पर यूजुअली कैनियंस एंड ट्रेंचेस मिलते हैं, तो डीप सी डाइवर्स के लिए थोड़ा सा मुश्किल हो जाता है. दैट इज वो वार्निंग दी जाती है कि स्पेशली इफ देयर आर पीपल हु आर गोइंग एनीवेयर नियर द स्लोप्स, तो उनको वार्निंग दी जाती है कि वॉच आउट फॉर ऑल दोस कैनियंस, ट्रेंचेस दैट यू आर लुकिंग आउट फॉर. ओके, तो यूजुअली यू शुड लुक आउट फॉर दोस. ओके, नेक्स्ट जो मिलता है दैट इज द डीप सी प्लेन्स. ये वाला पार्ट जो है ना, दैट इज व्हाट यू आर लुकिंग एट. ये बहुत वास्ट एंड बहुत हाउ डू यू से, दिस इज अ हाउ डू से वेरी स्मूथ रीजन. यूजुअली यहाँ पे कुछ मिलता नहीं है डीप सी प्लेन्स में, कोई मेजर फीचर्स नहीं मिलते आपको. डीप सी प्लेन खुद ही बहुत बड़ा फीचर हो जाता है. इट इज वेरी स्लोपिंग, gently sloping, flattest, smoothest regions होते हैं. What you find over here is sediments like clay, mud, silt, oozes, ये सब कुछ मिल जाता है. Oozes माने ना pelagic oozes माने ये यहाँ पर जो एनिमल्स रहते हैं ना, वो जब when they die finally, okay, तो वो डिकम्पोज होने लग जाते हैं. तो वो डिकम्पोज होने के बाद बिकॉज ऑफ दैट कंटिन्यूअस रिएक्शन विद वाटर, वो जो उनका डिकम्पोज मटेरियल बनता है वो थोड़ा सा ऐसे स्टिकी स्टिकी लिक्विड जैसा होता है, तो उसको ooze बुलाते हैं. ओके, दैट इज व्हाट वी कॉल एज एन ooze. तो ये जो ओजेस, सिल्ट्स, सेडिमेंट्स वगैरह होते हैं ये यहाँ मिल जाते हैं. एंड ये यूजुअली ओजेस आपको और कहीं नहीं मिलते क्योंकि ये एनिमल्स सिर्फ इस लेवल पे मिल जाते हैं. तो ओजेस आर यूजुअली जनरली रेयरली फाउंड. बाकी का सेडिमेंट्स आपको डिपेंडिंग ऑन विच ओशन यू आर इन एंड ओरिजिनल लेआउट कैसा था उस लैंड का, उस हिसाब से फिर सेडिमेंट्स एंड क्ले एंड जो भी मिलेगा वो वेरी करता है. ओके, किस तरह के सेडिमेंट्स मिलेंगे. तो वी आर लुकिंग एट दैट. मड स्पेशली किस तरह का मड मिलेगा, कौन से कलर का मिलेगा, कौन से एलिमेंट्स होंगे उसमें, तो वो वेरी करेगा. बट फॉर यू इट इज नॉट दैट इंपॉर्टेंट राइट नाउ. यू जस्ट रिमेंबर कि डीप सी प्लेन्स बहुत फ्लैट है एंड वेरी फीचरलेस होते हैं. बहुत कुछ मिलता नहीं है वहां पे. ओके, अदर देन क्ले एंड मड एंड सिल्ट, वहां पे ज्यादा कुछ मिलता नहीं है आपको. दैट इज अ डीप सी प्लेन. ओके, एंड लास्टली यू कम टू दीज ओशियनिक ट्रेंचेस. ये एक ट्रेंच दिखाई दे रहा है आपको, काफी डीप है. लाइक वी ऑलरेडी नो मरियाना ट्रेंच. तो ट्रेंच इज व्हाट वी आर एसेंशियली सेइंग इज कि वो एक अच्छा वी शेप, बहुत डीप ये होता है, गड्ढा होता है, डिप्रेशन होता है. ओके, so these are the deepest parts of the oceans. Usually steep sided होते हैं, narrow basins होते हैं. Okay, 3 to 5 kilometers deeper than the surroundings. On an average वो 3 to 5 kilometers deeper होते हैं. And usually वो continental slopes के base पे या फिर along island arcs अगर करते हैं. Remember जब हमने tectonic plates study किए थे तो मैंने कहा था कि when there are converging plates, okay, एक plate इस तरफ जा रहा है, दूसरा plate इस तरफ आ रहा है. When these two plates finally meet over here, तो वो एक दूसरे के साथ मिलने के बाद वन प्लेट इज सबडक्टेड बिलो दी अदर. राइट, वी हैड सेड ना कि एक प्लेट दूसरे के नीचे सबडक्ट हो जाता है. तो ये जो बनता है ना, दिस इज एक्चुअली अ ट्रेंच. ओके, दिस इज द फॉर्मेशन ऑफ अ ट्रेंच. तो यूजुअली when one plate is subducted beneath the other plate, तो what you will get essentially is this V-shaped formation of a trench. Okay, तो trenches usually subduction zones में भी बन जाते हैं. Okay, this is also one way of finding trenches. तो island arcs के along वगैरह मिल जाते हैं हमको. We are saying कि association is these are obviously if this is a subduction zone, तो उसका volcanoes and earthquakes के साथ deeply association होगा, deep association होगा. Okay, famous example of a oceanic trench is going to be the Mariana Trench, जिसका Challenger deep is almost 10,984 meters, almost 11 kilometers का depth है Challenger deep का. So वो Mariana Trench in the Western Pacific is a famous trench over there. Okay, so ये trenches थोड़े से difficult होते हैं. So these are your major, एक second ना, these are your major features. All right. These are your major features. Okay, you're talking about the continental shelves. द कॉन्टिनेंटल स्लोप, द डीप सी प्लेन्स एंड ओशियानिक बीच एंड ट्रेंचेस। ये मेजर फीचर्स हो गए। ओके, अब छोटे छोटे वाले देखते हैं, माइनर फीचर्स कंसिडर करते हैं। माइनर फीचर्स आर गोइंग टू बी मिड ओशियानिक रिजेस, सी माउंट्स, गियोल्स एंड अटोल्स। ओके, ये रहे माइनर फीचर्स। माइनर फीचर्स माने क्लियरली उनका हाइट या लेंथ या विड्थ इतना ज्यादा नहीं होगा, दैट इज व्हाट वी आर सेइंग। ओके, तो मिड ओशियानिक रिजेस जो होते हैं उसमें ये हम देख चुके हैं, जैसे मिड अटलांटिक रिज देखा था, सबमरीन माउंटेन रेंज होती है जो यूजुअली वोल्केनिक ओरिजिन की होती है। ओके, तो इट इज फॉर्म्ड बाय द अपवेलिंग ऑफ मैग्मा अलोंग अ डाइवर्जेंट प्लेट बाउंड्री। यू से कि एक दो प्लेट्स है जो दो डिफरेंट तरीके से दो डिफरेंट डायरेक्शंस में डाइवर्ज कर रहे हैं, तो यहाँ से लावा का अपवेलिंग होगा। ओके, एंड यहाँ पर फिर बीच में आपको एक माउंटेन रिज मिल जाएगा। ओके, दिस इज हाउ द लावा विल कम आउट फ्रॉम देयर एंड वहां पर छोटा सा माउंटेन बना लेता है। ओके, एंड वो बेसाल्टिक माउंटेन होगा ऑब्वियसली, बिकॉज वो बहुत जल्दी कूल हो जाएगा ओशन वाटर के कांटेक्ट में आके। सो क्लियरली, एंड ये जब ऐसा लंबा लंबा थ्रू आउट, अभी जैसे हमने इसमें देखा था अटलांटिक ओशन में देखा था, तो अटलांटिक ओशन के अलोंग उसके बीचों बीच ऐसा प्रॉपर रिज बना है वो, राइट, मिड अटलांटिक रिज। तो ऐसा पूरा का पूरा रिज, एंड दैट्स अ रेयर थिंग टू सी। सो वी आर सेइंग कि ये वाला जो फीचर होता है उसको हम माइनर फीचर बुलाएंगे ओशन फ्लोर का। ओके, सो दैट इज वन थिंग। Then the next feature is going to be a sea mount. Okay, sea mount हम कहते हैं कि it is a submerged mountain, कि ओरिजिनली एक वोल्केनिक माउंटेन था, वोल्केनिक माउंटेन था, फिर वो थोड़ा सा जमीन ऐसे सबमर्ज हो गया, नीचे चला गया है। ओके, बिकॉज पूरे ओशन फ्लोर जो है वो नीचे चला गया है, तो उसके साथ साथ वो माउंटेन भी नीचे सबमर्ज कर गया है। ओके, तो यूजुअली ये पीक्स जो होते हैं वो सी सर्फेस तक नहीं पहुंचते। ओके, यूजुअली दीस पीक्स आर बिलो द सी सर्फेस। ऑलराइट, वोल्केनिक आइलैंड्स जो होते हैं उनके पीक्स क्लियरली सी सर्फेस के ऊपर दिखाई देते हैं आपको। कैन यू मेक आउट ओवर हियर? ये रहा वोल्केनिक आइलैंड, वो लंबा है एंड क्लियरली इट इज टॉलर, एंड क्लियरली उसका जो सर्फेस है वो आपको क्लियरली ऊपर दिखाई देता है। अब वो अंडमान निकोबार आइलैंड्स नहीं दिखाई देते हमको जमीन के ऊपर क्लियरली, तो वी आर सेइंग दोस आर वोल्केनिक आइलैंड्स। ओके, लेकिन अगर यही वोल्केनिक आइलैंड नीचे सबमर्ज हो गया, थोड़ा सा सबसाइड हो गया, तो वो और उसका पीक सब कुछ पानी के नीचे चला जाता है। ओके, एंड उस केस में उसको सी माउंट कहेंगे। ओके, तो ये जो सी माउंट्स होते हैं वो कुछ 3 किलोमीटर to 4.5 किलोमीटर टॉल होते हैं। ओके, दे आर ऑल्सो प्रिटी टॉल। देन यू कम टू गियोस। ओके, अभी ये गियो किसी बंदे के नाम के पीछे नेम किया है, सम स्कैंडिनेवियन गाय जिनके नाम के पीछे इसको गियो बुलाते हैं। तो गियोस जो होते हैं they are flat top sea mounts. Okay, तो originally they start as sea mounts, कि originally एक volcanic island जैसा था, सब नीचे सबसाइड हो गया। ओके, लेकिन जब वो ऊपर थे ना, when they were above the surface of the water, तो यहाँ पे उनका अच्छा खासा इरोजन हो गया। दिख रहा है यहाँ पे, इट स्टार्टेड आउट एज अ सी माउंट, फिर और बढ़ गया तो वोल्केनिक आइलैंड बन गया। तो ये ऊपर का जो वोल्केनिक आइलैंड था उसका इरोजन हो गया एंड वो फ्लैट बन गया। ओके, बिकॉज ऑफ द विंड एंड एवरीथिंग उसका इरोजन हो गया एंड वो फ्लैट टॉप बन गया। उसके बाद जब उसका सबसिडेंस हो गया तो वो नीचे चला गया एंड अभी आपको नीचे ऐसे फ्लैट टॉप माउंट की तरह नजर आता है। ओके, तो उसको बुलाएंगे गियो। ओके, यूजुअली आपको सी माउंट एंड गियो का फर्क पूछते हैं, तो फर्क ये है कि सी माउंट जो होता है वो क्लियरली उसको पीक है। ओके, गियो को पीक नहीं है, इट इज फ्लैट टॉप। सी माउंट का यूजुअली हाइट थोड़ा ज्यादा होता है, गियोस की हाइट यूजुअली कम होती है बिकॉज उसका ऑलरेडी इरोजन हो चुका है ना, सो क्लियरली उसका हाइट थोड़ा कम होता है। इट इज एनीवेयर बिटवीन 900 to 4000 मीटर्स। ओके, 9 से 4 किलोमीटर तक होता है वो क्लियरली। ओके, 0.9 to 4 किलोमीटर तक आता है। तो वी आर सेइंग कि गियोस जो होते हैं वो छोटे होते हैं। ओके, एंड गियोस डेफिनेटली सबसाइड होके नीचे चले गए हैं, सी माउंट्स भी सबसाइड होके नीचे चले गए। पर कितना है कि ये इनके पीक्स है, सी माउंट्स के प्रॉपर पीक्स मिलते हैं एंड गियोस के प्रॉपर फ्लैट टॉप्स होते हैं। ओके, टेबल लैंड की तरह से फ्लैट टॉप्स मिल जाते हैं। दैट इज द डिफरेंस बिटवीन सी माउंट्स एंड गियोस। ओके, next you go to last minor feature is going to be an atoll. Okay, I have an atoll over here. See, this is what an atoll looks like. समुंदर के ऊपर वो ऐसा दिखाई देता है। You will see a circular ring of land. Okay, ये उसके कोरल्स है, आपको जो शाइन करते हुए नजर आ रहे हैं ना, वो शायद कोरल्स नजर आ रहे हैं आपको। ओके, सो वी आर सेइंग ये फ्लैट लैंड जैसा होता है। आई थिंक आई माइट हैव अनदर, हाँ, दिस इज अ फार बेटर वे ऑफ लुकिंग एट इट। ओके, तो लैंड होता है, लैंड का एक सर्कुलर पीस होता है और उसके बीच में यूजुअली और दूसरा लैंड नहीं होता है। यूजुअली मोर ऑफन देन नॉट यू डू नॉट फाइंड एनी लैंड ओवर हियर। ओके, बीच में आपको बस एक शैलो ब्रैकिश वाटर का लगून सा मिल जाता है। यू विल फाइंड अ लगून ऑफ दैट शैलो एंड ब्रैकिश वाटर। ओके, एंड इसके आसपास भी आपको बड़ा सारा कोई लैंड नहीं नजर आता है। ओके, सो दिस इज एसेंशियली व्हाट एन अटोल लुक्स लाइक। अपने लक्षद्वीप में यू विल फाइंड प्लेंटी ऑफ दीज अटोल्स, इसीलिए लक्षद्वीप आइलैंड्स आर सो फेमस फॉर टूरिज्म, बिकॉज आपको ये बड़ी सारी सुंदर अटोल्स मिल जाते हैं वहां पर। ओके, सो ये अटोल्स से यूजुअली कभी कभी आपको पाम ट्रीज वगैरह मिल जाते हैं। अभी इन्होंने तो काफी कुछ डेवलपमेंट करा लिया है यहाँ पे क्लियरली, लेकिन यूजुअली अटोल दिख रहा है ना तेरे कुछ हाउसेस जैसा भी दिख रहा है मुझको यहाँ पे, एंड ग्रीनरी वगैरह भी दिखाई दे रही है। तो जब आप नॉर्मल अटोल्स देखते हो तो यू जस्ट हैव अ फ्यू पाम ट्रीज और समथिंग लाइक दैट। ओके, नाउ लेट्स सी हाउ दीज अटोल्स आर फॉर्म्ड, बिकॉज दिस इज अ वियर्ड वे ऑफ लुकिंग एट इट, राइट? आपको कैसे पता कि अटोल्स कैसे बन रहे हैं दिख रहे हैं? तो अटोल्स बनने का तरीका ये होता है। यूजुअली क्या होता है ना कि एक अच्छा खासा एक्टिव वोल्केनो रहता है, आइलैंड, वोल्केनिक आइलैंड है, ओके। तो यू आर सेइंग इन द मिडल ऑफ द सी एक वोल्केनो राइज करता है एंड समुद्र के पानी के ऊपर, उसके सरफेस के ऊपर वो दिखाई देने लगता है, ओके। सो दिस इज अ वोल्केनो। देन उसके आजू बाजू धीरे धीरे एक फ्रिंजिंग रीफ बनने लगती है। कैन यू सी दिस रीफ? हाँ, तो रीफ बनने लगती है, फ्रिंजिंग रीफ बनने लगती है। फ्रिंजिंग रीफ मतलब ऐसे बॉर्डर को जब रीफ, कोरल रीफ्स बनना शुरू हो जाते हैं तो उसको फ्रिंजिंग रीफ बुलाते हैं, ओके। फ्रिंज क्या होता है? बॉर्डर। किसी भी चीज का जो बॉर्डर होता है उसको फ्रिंज बुलाते हैं। सो वी आर सेइंग कि उसके आजू बाजू जब रीफ्स, कोरल रीफ्स बनना शुरू हो जाते हैं तो उसको फ्रिंजिंग रीफ बुलाते हैं, ओके। अब इसके साथ क्या हो रहा है, ये जो वोल्केनो है वो तो सबसाइड कर रहा है, ओके। दिस इज व्हाट इज हैपनिंग विद द वोल्केनो। तो वोल्केनो स्टार्ट्स टू सबसाइड। रीफ क्या करता है ऐसे केस में? The coral reef always has a tendency to move seawards and upwards. Okay, that is what coral reefs do. वो हमेशा सॉल्टी पानी की तरफ जाते हैं, ये उनकी खासियत होती है। They will always try to move towards the salty water. वो लैंड से अटैच करने की कोशिश नहीं कर रहे खुद को, वो पानी के साथ ग्रो करते हैं, ब्रैकिश ये सॉल्टी वाटर, सेलाइन वाटर के साथ ग्रो करते हैं। तो दे विल ट्राई, इवन इफ द लैंड इज सिंकिंग, इवन इफ द वोल्केनिक आइलैंड इज सिंकिंग, द रीफ्स विल ट्राई टू एक्सटेंड देमसेल्व्स वे फॉरवर्ड इनटू द सी, ओके। तो ये लैंड भी अगर सिंक कर गया तो ओरिजिनल रीफ बाहर की तरफ ग्रो करना शुरू कर देती है एंड बैरियर रीफ बना देती है, ओके। जो रीफ इससे अटैच हो गई थी वो रीफ उसके साथ साथ नीचे डूब गई है, ओके। एंड वो ऊपर की तरफ एंड बाहर की तरफ ग्रो करने लगा है। समझ रहा है आपको? ओके, द रीफ ऑलवेज ट्राइज टू ग्रो either upwards towards the sea surface or outwards from the land, okay, that is what the reef is always going to do. तो इसकी वजह से फिर ये बैरियर रीफ बन जाता है, जैसे वो ऑस्ट्रेलिया का ग्रेट बैरियर रीफ है ना, वो इस तरह से बना है, ओके। बिकॉज द लैंड केप्ट सिंकिंग एंड देन उसके बाद वो रीफ स्टार्टेड टू ग्रो आउटवर्ड, ओके। एंड देन फाइनली ये लैंड पूरी तरह डूब जाता है नीचे अंदर की तरफ, एंड बाहर आपको बस ये सर्कुलर रिंग मिल जाता है कोरल्स का, ओके। दैट इज एसेंशियली व्हाट एन अटोल इज। तो यूजुअली जब आप कोरल रीफ स्टडी करते हो तो साथ साथ अटोल स्टडी करते हो। वी हैव डन दिस इन जियोमॉर्फोलॉजी व्हेन वी डिड कोस्टल वेव्स, हाँ, तभी हमने किया था ये कि अटोल्स कैसे बनते हैं, ओके। सो दिस वाज डार्विन्स मेथड ऑफ सब्सिडेंस, जो अटोल्स के लिए कंसिडर किया था हमने। सो दिस इज वन वे ऑफ फॉर्मेशन ऑफ अटोल्स, ओके। सो आपको दोनों का मिल जाता है, लेकिन दिस इज एसेंशियली व्हाट हाउ अटोल्स आर फॉर्म। ओरिजिनली वोल्केनिक आइलैंड होगा, उसके बाजू बाजू में कोरल रीफ बनेगा, फिर वो आइलैंड धीरे धीरे सिंक करने लगेगा, तो कोरल रीफ स्टार्ट्स टू ग्रो आउटवर्ड, वो उस आइलैंड से दूर एंड समुद्र के पास एंड ऊपर की तरफ ग्रो करना शुरू करेगा, जिसकी वजह से आपको आइलैंड के बाजू में एक ऐसा रिंग दिखेगा। फाइनली द आइलैंड इज गोइंग टू कंप्लीटली सबमर्ज इनटू द लैंड, इनटू द वाटर, एंड आपको आइलैंड कहीं नहीं नजर आएगा, इवन दो इट एग्जिस्ट बीनीथ द वाटर। आपको नजर नहीं आ रहा है कि कोई आइलैंड वहां है, बट क्लियरली द आइलैंड एग्जिस्ट बीनीथ द वाटर, इसीलिए ऊपर की तरफ वो शैलो सा लगून बन गया है, लेकिन इट गेट्स कवर्ड ऑलमोस्ट बाय वाटर। जी सर? नहीं सर। कोई बात नहीं सर, ये लेक्चर वैसे भी ऑनलाइन है तो क्या क्या ही कर सकते हैं अभी। ऑलराइट, ठीक है। सो दिस इज एसेंशियली व्हाट अटोल्स आर। हाँ, हो गया अपना? हाँ जी। सो दिस इज हाउ वी हैव द मेजर एंड माइनर रिलीफ फीचर्स ऑफ द ओशन फ्लोर। वी लुक्ड एट कॉन्टिनेंटल शेल्फ्स, कॉन्टिनेंटल slopes, deep sea plains and oceanic deeps and trenches, which are the major oceanic features. And then you have the minor features, which are mid-oceanic ridges, seamounts, geos and atolls. Okay, ये minor features हो गए। ये भी एक क्वेश्चन पूछते हैं आपको यूपीएससी एग्जाम्स में, कि चार ऑप्शंस देंगे आपको ये 8 में से, एंड बोलेंगे इसमें से कौन सा मेजर है या माइनर फीचर है ओशन फ्लोर का। तो आपको ये चार माइनर पता होने चाहिए। मेजर तो बहुत बड़े होते हैं ना, लाइक कॉन्टिनेंटल स्लोप, डीप सी प्लेन्स, ओशियनिक डीप, वो बहुत बड़े बड़े फीचर्स है क्लियरली। ये तो छोटे छोटे है, ऐसे मिड ओशियनिक रिजेस, सी माउंट्स, गियोस, अटोल्स, छोटे थे ना वो, कितना क्या 4 किलोमीटर का हाइट है उसका, उसको बड़ा कैसे बुला सकते हैं? अभी बाकी का ओशन देखिए कितना बड़ा है। नहीं, छोटा है ना, कंपैरेटिवली छोटा है, सो वील कॉल इट छोटा, ओके, ठीक है। नेक्स्ट फीचर इज गोइंग टू बी द टेम्परेचर ऑफ द ओशंस, ओके, ये जरूरी है हमारे लिए। बिफोर आई बिगिन टेम्परेचर, या फिर मैं टेम्परेचर एंड सैलिनिटी कर लेती हूँ, एंड ओशन करंट से पहले क्वेश्चन आंसर सेशन कर ले, हाँ, थोड़ा सा इसके ऊपर बेस्ड वो कर लेते हैं। लेट्स डू दैट। टेम्परेचर ऑफ ओशंस इसलिए देखना जरूरी होता है बिकॉज व्हेन वी स्टडी ओशनोग्राफी सब पढ़ते हैं या उसका स्टडी करते हैं, जैसे फॉर एग्जांपल अभी अपना मॉनसून लेट आया, राइट, ऑलमोस्ट अ मंथ लेट। द रीजन इज ओशन का टेम्परेचर वेरी कर गया, एल नीनो कहीं स्ट्रांग हो गया था, तो उसकी वजह से हमारा ये जो सदर्न ऑसिलेशन है वो पूरा बिगड़ गया। जिस कोस्ट पे ठंडा होना चाहिए था उस वो कोस्ट गर्म हो गया, जो कोस्ट गर्म होना चाहिए था वो ठंडा हो गया, अपने इंडियन ओशन का टेम्परेचर बिगड़ गया एंड उसकी वजह से अपना मानसून थोड़ा लेट हो गया। ओके, एंड अभी तो भरोसा नहीं हो रहा है हमको कि किस तरह का मानसून आ रहा है, राइट? सो वी आर सेइंग कि ये जो अरे नहीं, यू आर नॉट वरीड ओवर इट। एवरी टाइम आई लुक आउटसाइड माय balcony it is always raining। रात को देखो, दिन में देखो, कभी भी देखो बारिश ही हो रही है, एंड I'm like okay I understand but I'm pretty sure, let alone me, this is not going to go very well down on the crops as well, बिकॉज ग्रोइंग सीजन को कैसे, लाइक आप ऐसे ग्रोइंग सीजन में इतना सारा पानी उसके ऊपर बकेट 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 डाल देंगे, बट दैट इज, अब क्या वो गवर्नमेंट देखे अपना जैसे करना है वैसे। या वी आर ओके, वी आर सेइंग कि ओशन टेम्परेचर्स इंपॉर्टेंट होते हैं, क्लाइमेट को अफेक्ट करता है, स्पेशली मॉनसून क्लाइमेट को जैसे अफेक्ट होता है। ओशन टेम्परेचर्स यूजुअली मरीन ऑर्गेनिजम्स के लाइफ के लिए भी इंपॉर्टेंट होते हैं। हमने इससे पहले देखा था कि ओशन टेम्परेचर ऑल्सो इंपॉर्टेंट फॉर द कोरल रीफ्स, है ना। ब्लीचिंग ऑफ कोरल रीफ्स का नाम सुना है आपने, यू हर्ड ऑफ दिस फेनोमेनन, एंड यू नो दैट व्हेन पीपल से दैट द कोरल रीफ्स आर बीइंग ब्लीच्ड, देन वो क्लियरली एक बड़ा एनवायरमेंटल कंसर्न होता है। जैसे ये दिस यहाँ पर आपको कोरल रीफ मिलता है ना, ऑस्ट्रेलिया के ये नॉर्थ ईस्ट सेक्शन पे क्वींसलैंड के बाजू में आपको क्लियरली वो ग्रेट बैरियर रीफ मिल जाता है। ओके, उसका वो ब्लीच हो रहा है, जिसके जो हमारे लिए बहुत बड़ा कंसर्न है। द रीजन बीइंग कि जब कोरल रीफ्स ब्लीच हो जाते हैं तो इसका मतलब ये कि वाटर टेम्परेचर्स हैव रिजन, एंड उन्होंने वो उनका वो स्ट्रेस रिस्पॉन्स होता है, कोरल रीफ्स का वो स्ट्रेस रिस्पॉन्स होता है कि वो उठाकर वो जो उसके अंदर जूजैंथल होता है जो उनको खाना भी देता है एंड कलर भी देता है, वो जो कोरल्स के खूबसूरत कलर्स होते हैं ना, दे कम फ्रॉम दैट एल्गी कॉल्ड एज जूजैंथल, जिसको वो अपने अंदर अपनी बॉडी के अंदर प्रोटेक्शन प्रोवाइड करते हैं, घर दे देते हैं, एंड वो उनको खाना भी प्रोवाइड करता है। सो उनका स्ट्रेस रिस्पॉन्स होता है, फॉर एग्जाम्पल वो नीजक रिस्पॉन्स है उनका, कि अगर टेम्परेचर बढ़ गया तो वो इरिटेट हो जाते हैं कोरल्स एंड वो जूजैंथल को बाहर निकाल देते हैं। ओके, जूजैंथल अगर बाहर चला गया तो उनका रंग नहीं बचता है, उनको रंग कौन देगा उसके बाद, तो उनका रंग नहीं बचता है, इसीलिए यू फील दैट द कोरल्स आर बीइंग ब्लीच्ड, वैसे व्हाइट व्हाइट कलर के नजर आने लगते हैं आपको। ओके, कलरलेस नजर आने लगते हैं। एंड दूसरी बात, उनका खाना चला जाता है। प्रॉब्लम ये नहीं है कि वो कलरलेस हो जाते हैं, कलरलेस होने से वो मर नहीं जाते, लेकिन खाना नहीं मिलेगा तो वो मर जाएंगे। ओके, तो दैट इज अ प्रॉब्लम विद कोरल्स। सो वो इश्यू हो जाता है। सो क्लियरली वाटर टेम्परेचर इज गोइंग टू अफेक्ट द रेस्ट ऑफ द मरीन ऑर्गेनिज्म ऑल्सो, एंड कोरल्स इज जस्ट वन ऑफ देम, राइट? बाकी के मरीन ऑर्गेनिजम्स भी अफेक्ट हो जाते हैं। सो इसलिए वाटर टेम्परेचर इंपॉर्टेंट होता है स्टडी करना। ओके, नाउ लेट्स सी व्हिच आर द फैक्टर्स अफेक्टिंग टेम्परेचर डिस्ट्रीब्यूशन। लैटिट्यूड्स, क्लियरली ऑब्वियसली इंसोलेशन सबसे ज्यादा आपको ट्रॉपिक्स में मिलता है। ओके, उसके बाहर आपको जितना भी इंसोलेशन मिलता है वो सारा इंक्लाइंड फैशन में मिलता है, तो क्लियरली उतना हीट नहीं मिलता है सन से। ओके, अगर मुझे बताइए, अगर डायरेक्ट सनरेज मिलते हो 90 डिग्री से तो उसमें ज्यादा हीट मिलेगा या इंक्लाइंड सनरेज में मिलेगा? डायरेक्ट में, क्योंकि इंक्लाइंड में the possibility of getting scattered, of being reflected, of being absorbed by the atmosphere वो बहुत बदल जाता है, राइट? वो चेंज हो जाता है। तो क्लियरली जितना यूजुअली जो मिडिल लैटिट्यूड्स होते हैं, ट्रॉपिकल रीजन्स होते हैं, वहां पे उन लैटिट्यूड्स में यूजुअली ज्यादा हीट मिल जाती है। ओके, एंड देन ये टेम्परेचर जो होता है वो इक्वेटर टू पोल्स डिक्रीज होते जाता है, क्योंकि सनलाइट ही नहीं पहुंचती पोल्स तक, हमेशा सनलाइट नहीं पहुंचती। ओके, सो क्लियरली दैट हैपेंस। सो लैटिट्यूड के हिसाब से टेम्परेचर बदल जाता है। You also have to understand that there is an unequal distribution of water and land. Okay, नॉर्दर्न हेमिस्फीयर में अगर आप देख लीजिए, ये ब्राजील के ऊपर का अपना, दिस इज द इक्वेटर, ये कंधा है और यहाँ पे इक्वेटर है। ओके, तो इसके आसपास इक्वेटर है हमारा। सो वी आर सेइंग यूजुअली, अभी देखिए ऊपर नॉर्दर्न हेमिस्फीयर में कितना सारा लैंड है एज अपोज टू वाटर। ओके, एंड नीचे देखिए कितना कम लैंड है एज अपोज टू वाटर। ओके, द रीजन व्हाई वी आर डिस्कसिंग दिस इज बिकॉज लैंड की खासियत होती है कि वो गर्मी में बहुत ज्यादा गर्म हो जाता है और ठंडी में बहुत ज्यादा जल्दी ठंडा भी हो जाता है। ओके, क्लियरली, तो इसका मतलब समर सीजन्स में ये पूरा लैंड एकदम तप जाएगा। लैंड तप जाएगा तो क्लियरली बाजू वाला पानी भी तप जाएगा। हाँ, तो जो भी पानी उसके करीब है, या फिर ये अंदर का, ये देखिए ये कैस्पियन सी, समझ में इसका टेम्परेचर सोचिए, ये रेड सी इसका टेम्परेचर सोचिए, ये मेडिटेरेनियन उसका टेम्परेचर देखिए, तो ये सारे क्लोज, सेमी एनक्लोज्ड या क्लोज्ड सीज हो जाते हैं, तो उनका टेम्परेचर अपने आप बढ़ जाएगा। ओके, जब लैंड का टेम्परेचर, आसपास के लैंड का टेम्परेचर बढ़ जाता है तो पानी का भी थोड़ा बहुत बढ़ेगा। इवन तो पानी की वैसी कैरेक्टरिस्टिक नहीं होता है लैंड की तरह कि बहुत जल्दी गर्म हो या बहुत जल्दी ठंडा हो जाए, लेकिन उससे फर्क तो पड़ेगा उसको। ओके, सो यू आर सेइंग कि ऑब्वियसली दैट मैटर्स अ लॉट। तो यूजुअली ये जो नॉर्दर्न एरिया के ओशंस होते हैं या सीज होते हैं, उनके टेम्परेचर अक्सर थोड़े से ज्यादा होते हैं एज कम्पेयर टू द सदर्न सीज और सदर्न हेमिस्फीयर। ओके, ठीक है, so that is there. Okay, so oceans in northern hemisphere will usually have higher temperatures. Prevailing wind is one more thing. प्रिवेलिंग विंड माने आपके पास दो मेजर विंड्स होते हैं, एक ट्रेड विंड्स एंड दूसरा वेस्टर्लीज। अब ट्रेड विंड्स कहाँ से कहाँ ब्लो करते हैं? जैसे दिस इज द इक्वेटर एंड दिस इज 30 डिग्रीज नॉर्थ, इसको हम सब ट्रॉपिकल हाई बुलाएंगे। ओके, एंड यहाँ पर 30 डिग्री साउथ है, जिसको हम अनदर सब ट्रॉपिकल हाई बुलाएंगे, ओके। और इसके ऊपर होगा आपका सब पोलर लो, जो 60 डिग्रीज नॉर्थ पे आएगा, एंड यहाँ पे नीचे और एक 60 डिग्री साउथ पे यू विल हैव अनदर सब पोलर लो, ओके। ये लो प्रेशर बेल्ट, इक्वेटर लो प्रेशर बेल्ट है, सब ट्रॉपिकल हाई हाई प्रेशर बेल्ट है, एंड सब पोलर लो वंस अगेन लो प्रेशर बेल्ट है, ओके। हवा हमेशा कहाँ से कहाँ जाएगी, हाई प्रेशर बेल्ट से लो प्रेशर बेल्ट की तरफ, ओके। तो यहाँ पर हवा नॉर्थ ईस्ट ट्रेड विंड बन के जाती है, और यहाँ पर साउथ ईस्ट ट्रेड विंड बन के जाएगी, ओके। दिस विल बी द साउथ ईस्ट ट्रेड विंड्स, दीज आर द ट्रेड विंड्स, हाँ अग्री। यहाँ पर हवा यूजुअली वेस्टर्लीज बनकर घूमती है, ओके। Between 30 to 60 north and 32 degrees south, 30 to 60 degrees south, the wind will flow as westerlies. थोड़ा सा जनरली वेस्टर्न डायरेक्शन से चलेगा वो विंड, ओके। सो अब ये विंड्स जो होते हैं, ये यूजुअली यू हैव टू चेक आउट कि वो किस रीजन में शोर से लैंड की तरफ अगर जाते होंगे तो उनको ऑफशोर विंड्स कहेंगे, ओके। इफ दे आर मूविंग फ्रॉम द शोर टुवर्ड्स द लैंड, then they will be offshore, okay. If they are moving from the sea towards the land, they will be called as onshore winds, okay. अब डिपेंडिंग ऑन वेदर दे आर ऑनशोर या ऑफशोर, ये कोस्ट का टेम्परेचर को या पानी को अफेक्ट करते हैं, ओके। लेट्स अंडरस्टैंड व्हाट ऑफशोर विंड्स डू। ऑफशोर विंड्स क्या करते हैं, लैंड की तरफ से आते हैं, वहां का जो सरफेस का पानी होता है ओशन कोस्ट का, उसको पूरी तरह से हटा देते हैं, ओके। दे ट्राई टू रिमूव दैट वाटर। वंस दैट वाटर इज रिमूव्ड, तो उसको सब्स्टिट्यूट करने के लिए नीचे से कोल्ड पानी ऊपर आ जाएगा, तो ऑब्वियसली शोर का पानी ठंडा हो जाता है, ओके। सो वो उस विंड की रिजल्ट है, इट्स अ कॉन्सिक्वेंस ऑफ दैट विंड ब्लोइंग इन दैट रीजन, दैट ऑफशोर विंड ब्लोइंग इन दैट रीजन, कि वो यूजुअली सरफेस का पानी हटा देता है सामने से, नीचे से ठंडा पानी ऊपर आ जाएगा, एंड ऑब्वियसली उसको सब्स्टिट्यूट करने, इसलिए वो शोर पूरा ठंडा हो जाएगा, ओके। तो टेम्परेचर्स विल फॉल। ऑनशोर विंड्स क्या करते हैं, ऑनशोर विंड्स दुनिया भर का सरफेस गर्म पानी, जो सरफेस वार्म वाटर जो होता है, वो लाके कोस्ट पे वॉशअप कर देते हैं, ओके। वहां पे जाके पाइल अप कर देते हैं, तो वहां से कोस्ट का टेम्परेचर यूजुअली बढ़ जाता है, ओके। सो दिस इज एसेंशियली व्हाट ऑनशोर एंड ऑफशोर विंड्स विल डू, ओके। It's very logical. Offshore winds will drive away the water, because of which नीचे से ठंडा पानी ऊपर आ जाएगा, cold water का upwelling हो जाएगा। एंड ऑनशोर विंड्स जो होते हैं, जो समुंदर से लैंड की तरफ जाते हैं, वो यूजुअली सारा गर्म पानी लेके उस कोस्ट के अलोंग पाइल कर देंगे, ओके। दे विल पाइल अप ऑल दैट कोल्ड वाटर ओवर देयर, ओके, वार्म वाटर ओवर देयर। सो उसकी वजह से टेम्परेचर्स राइज होंगे, ओके, ठीक है। You are here, okay. No, I just realized I'll switch back to English now completely, now that you both are here. Okay. Next is the ocean currents, okay. Now clearly you have warm ocean currents, cold ocean currents. Warm ocean currents are going to go from the equator towards the poles, okay. From the equator, whatever travels to the poles is usually a warm ocean current. And cold ocean currents will go from the poles towards the equator, okay. What will a warm ocean current do? It will try to raise the temperatures along whichever coast it is going. And what will a cold ocean current do? It will obviously bring down the temperatures, okay. That is normal. Enclosed seas, this thing that I was telling you, enclosed seas usually are surrounded by water on all their sides, okay. This is a good example of an enclosed sea. Let's look at this. ये नजर आ रहा है आपको? Can you make out this one? Caspian Sea looks like a seahorse, ना? So Caspian Sea is a very good example of an enclosed sea, okay. So is this one, Aral Sea. This one, can you make out the Aral Sea over? ये Kazakhstan, Uzbekistan के बीच में जो है, oh, can you make out that one? That's the Aral Sea, okay. This is a huge environmental concern. It used to have a sidebar people. It used to, Aral Sea used to lie, it used to be much larger in size than you can see it right now. It lies between Kazakhstan and Uzbekistan. This area used to be ruled by the, it used to be under the dominion or sovereignty of USSR at that time. Remember, before USSR split up, right? So before it was just Russia, the Russian Federation, it was USSR. So at that time, this place, this entire region used to be under their rule. And they wanted to grow some cotton over here. So there are two rivers. This is an endorheic basin. I'll write down what an endorheic basin is. I don't know yet when I'm going to explain this part to you, because okay, this is what an endorheic basin means. Endorheic basin means you have inland receiving. Okay, you have rivers coming in and pouring into that lake. Okay, that is an endorheic basin. So endorheic basins जो होते हैं, the Aral Sea famously is an endorheic basin. And we are saying that what happens over here is that there were two major rivers coming over here. One was called as Amu Darya, the other was called as Sir Darya. Okay, so these two rivers were coming in and they were pouring their water into the Aral Sea. Okay, and clearly there was a lot of economic activities, fishing, boating, tourism, and all going on into the Aral Sea at that time. But what the USSR government did is, because they wanted to grow cotton, they diverted the water from these rivers towards other irrigation projects. Okay, If clearly Amu Darya and Sir Darya were not pouring enough into the Aral Sea anymore, the size of the Aral Sea started shrinking. Okay, open say this is a pretty hot region now. Meaning the evaporation is higher. Okay, especially on this side, the evaporation is higher. So what happened is that because of that, lack of water received from the rivers, this lake started shrinking. Okay, this place started shrinking. It's not a lake, but the water body started shrinking, and now it is too small. You can clearly see the ocean floor, like the sea floor over there. Okay, it is that small and that lacking in water now. Kazakhstan has made some efforts to, build up their end of the part, but Uzbekistan side, it is still a little dryish. Okay, so this is a major environmental concern, Aral Sea, because you don't want water bodies drying up, right? You don't want that happening. It also affects the marine life inside there, so that is also a problem. Okay. Caspian Sea is another famous one. Then there is a Dead Sea over here. You can't see it in the map, but clearly on the border of Israel and Jordan over here, there is a water body called as the Dead Sea. Famous river, famous sea, famous lake because it is very deep. It is situated inside the Arabian Rift. So clearly it is what do you say? Not Arabian Rift नहीं बुलाना चाहिए. Arabian ही Rift बुलाना चाहिए. There's a transform fault actually. Between the Arabian and the African plates, there's a transform fault, and inside that transform fault sits the Dead Sea. Okay, so it is pretty deep, it is pretty low also, and clearly because of because of that high salinity and the presence of so many minerals, the buoyancy is very high. You don't really need to go and swim over there. You float. You just float over there. Famous, na? Dead Sea is famous for that part. So these are enclosed bodies. Okay. On the other hand, Red Sea, which is completely surrounded by land, and you just have a single strait out of here, that is a semi-enclosed body. So is the Mediterranean. So many straits, but it is still surrounded by land on all sides. So there are very single narrow passages of water leading it into other seas or places. Okay. So these straits will, how do you say, separate them from the rest of the water bodies. But this will be a semi-enclosed sea. Okay. The Black Sea also a semi-enclosed sea. So you're saying these that you're looking at will be semi-enclosed seas, whereas Caspian, Aral Sea, or the Dead Sea over here are clearly enclosed seas. Okay, is that definition good? Right. Now let's see what happens to enclosed seas. Okay, in lower latitudes, clearly the temperatures will be higher. The land temperatures will be higher over there because they are in lower latitudes. Okay, so those seas will also have higher temperatures. They will tend to take on the temperature of the land surrounding them. Okay, so these seas will usually have higher temperatures than the open seas. And what happens in higher latitudes? In higher latitudes, usually these seas, they call more lower temperatures than the open seas because now you are affected by the amount of insulation you're getting. Okay, so this is the difference between the enclosed seas at lower or higher latitudes. Okay, is this good, people? All right, these are your hottest oceans ranked by temperature. Start with the Indian Ocean. It's a small ocean, right? Indian Ocean is Indian Ocean is a small ocean. So it's half an ocean. Famously, Indian Ocean is called half an ocean because you don't see, normally, if you look at the Atlantic, you see a northern Atlantic, you see a southern Atlantic. You look at the Pacific, it's the largest ocean. You see a northern part, you see a southern part. Can you see a proper northern part for the Indian Ocean? No, it is just a small little water body over there, right? So clearly it is called half an ocean. Okay. So Indian Ocean happens to be the hottest ocean. Okay. Followed by, you have the Pacific, then the Atlantic, then the Antarctic or the Southern Ocean, and lastly the Arctic Ocean. Okay. So this is the order of the oceans ranked by temperature. Okay. Fathead on the phone, come and sit here. All right. Now you look at the distribution of temperature in oceans. You've studied the general rules for how temperature gets distributed. And don't talk to your friends, okay? And this is the distribution. Now you look at the horizontal distribution and the vertical distribution of temperature, okay? Let's look at the vertical distribution. Normally, in tropical regions, the surface temperature will be higher, okay? And then clearly the ocean temperature keeps on falling, okay? As in how you go deep into the ocean, the temperature keeps on falling. This is the graph for that, okay? This is the graph for the temperature and this is the recording for the temperature at various levels, okay? At various depths. So you are saying that the surface temperature is usually higher in the tropical regions, and then it keeps dropping as in how you go downwards, okay? More into the depth of the ocean. So temperature decreases with increasing depth, usually in the tropical regions. maximum temperature is always at the surface of the ocean. Average temperature is some 27 degrees Celsius, right? We are saying the average temperature is some 27 degrees Celsius because it receives all that sunlight and it will keep all that heat, not as much as land usually tries to retain, but a little amount of heat it will get, okay? And then that heat is transmitted to the lower sections, okay? So it is always the upper layer which gets heated, and then the lower layer which comes in contact with the upper layer and thus gets heated. Similar way in which atmosphere is heated. How is atmosphere heated? First, the earth heats up, and then the layer closest to the atmosphere heats up, okay? And then that layer imparts heat to the layer above it, okay? And that's how that conduction, through the process of conduction, the heat keeps getting transferred. And we've done this now before. We have already explained this before. Okay. So similarly, you say that earlier the topmost layer of the ocean or the sea water gets heated, and that layer usually transmits heat to the layers below it. Okay, that's how it happens. Now, this is the temperature depth profile. See, look at this depth profile. You are saying that the first layer, this is the first layer, the one that is around 500 meters. So you are saying this layer is the top layer, and the temperature range is anywhere between 20 to 25 degrees Celsius. Okay. So this layer is ever present in the tropical regions, and in the mid latitudes it develops only in summer. What happens in winter in the mid latitudes? That layer freezes over, right? Agree? Because the temperature falls a lot. So that temperature usually, that entire layer freezes over, and it is ice. The density is far lesser than water, so clearly it floats on that water. You know, that is how it works. You know now that in colder regions, usually you'll find that the upper layer of water is frozen. We used to call this anomalous behavior of water and all that thing also, right? Remember? And the upper layer is frozen, and clearly below it, all the marine life exists because that layer is unfrozen and there is cold water, but there is still water. It is still in a liquid state. Okay? Okay? So this is the first layer. Okay, this much at 500 meters depth, it is the first layer. Now you see this part. Can you see this graph? There is a rapid decline in temperature. So you say the temperature was somewhere around 22 degrees Celsius at this point, and now it has clearly fallen to 4 degrees Celsius. Okay, very rapidly within a short depth of within a short height of depth, it has fallen down very quickly. There is a rapid decrease in temperature with increasing depth, and this layer is some 500 to 1000 meters thick. Okay, so within that depth, within this depth, we are saying within this depth, the temperature has rapidly fallen. Okay, straight from 20 to 22 degrees Celsius to almost 4 degrees Celsius. Okay, that much decrease has happened for the temperature over there. And the last layer, this is the last layer. We are saying this third layer is very cold and it extends up to the ocean floor. Okay, but even if you go right down up to the ocean floor, the ice, it never freezes, the water never freezes over there. One very important reason being because even if the temperature reaches freezing point, okay, even if ice is formed, will the ice remain there? No. How can ice remain there? Ice has a lesser density than water. It will obviously float upwards. Okay. So clearly, this level at the bottom is never ever frozen. Okay. Please remember that. All right. Now this was the vertical distribution. We look at the horizontal distribution. Okay. The horizontal distribution of temperature works this way, that the temperature decreases from the equator towards the poles. Okay, temperature will always decrease from the equator towards the poles. The water temperature or the temperature of the seas closer to the equator or within the tropics will always tend to be a little higher. Okay, so this is the average one. You have an average 20 degrees Celsius temperature at around 20 degrees north and south, average 14 degrees Celsius temperature at around 40 degrees north and south, and then 0 degrees Celsius near the poles. Okay, you will usually find a 0 degrees Celsius near the poles. Please remember, oceans in the northern hemisphere will always record a bit of higher temperatures because there is more land present over there. So the heating will obviously a little be higher. The heating will obviously be a little more higher. So temperatures will be a little higher. Okay, okay. This is good. Now you understand, right? That if there is unequal distribution of water and land, then obviously it is going to affect the water beside it. Okay, okay. Now you check out the salinity. You get questions over this. You get questions based on this. So please pay good attention. This is one of their favorite questions. Dissolved salts in seawater. This is a table that appears in the NCERT textbook. Okay, so if ever NCERT publishes any sort of tables, any sort of small, know this or did you know or something like that, please bear in mind that they will ask you questions on that. Okay. So this is a table. You need to know that we say dissolved salts in seawater. This is a gram of salt. How many grams of salt per kg of water? Okay. So chlorine has the highest concentration. Chlorine always appears in the highest proportion, followed by sodium. Chlorine and sodium, we know we should expect these to be in a higher proportion, right? Followed by sulfate, then magnesium, then calcium. Okay. At least potassium tak to yaad rakhiye. Please remember at least this order, that the topmost salt will always be chlorine. followed by sodium, followed by sulfate, followed by magnesium, followed by calcium, and then potassium. Okay. This is the order in which the salts will usually appear in seawater, as dissolved salts in seawater. Okay. And this is the percentage of salts in those oceans. Okay. So sodium chloride, this is a standard thing. Anywhere, any place you pick up an ocean water, this is usually the kind of percentage you will find for the salts in the oceans. Okay. So sodium chloride will appear in the maximum amount around 77%, and then followed by magnesium chloride, followed by magnesium sulfate, followed by calcium sulfate, and then potassium sulfate. Okay. This looks boring, but I promise you that when this becomes a question and you remember you had seen this in somewhere in the notes, but you did not bother to read it, you will regret it in your exams, and I don't want you to do that. So please pay attention to the tables. Okay, people? Now let's try to understand what salinity is. Salinity is the total content of dissolved salts. Okay. What is the total content of dissolved salts in the water should ideally be considered salinity. So you say suppose I have 1 kg of water, then how many grams of salts, all kinds of salts are dissolved in it. Okay. And that should give you the salinity. Okay. So usually it is expressed as parts per thousand or ppt. That is how you express salinity. Average salinity of oceans is considered 35 ppt. Okay, that is 35 is considered the normal average salinity for oceans, and a salinity of 24.7 ppt is the upper limit to demarcate brackish water. Okay, so if any you at 24.7, you should call that water. You should ideally call that this is the limit of brackish water. Above that, you should be calling that saline water. Okay, ठीक है? All right, and these are the highest. These are the water bodies with highest salinity. This is one thing I'll advise you not to pick up from NCERT books. I don't know which book they were referring to or whatever reference book they were referring to. They do not have the ideal figures. Okay, so this is the highest salinity in water bodies. Don Juan करके कोई pond है in Antarctica. It has a salinity of 440 ppt. Okay, now this is very cold. You should know this also, that the colder water gets, the denser it gets, and then obviously the salinity will be higher. Okay. Lake Assal in Djibouti, that has a salinity of around 348. Now that is understandable. It's close, it's hot, and clearly that's one reason why, and the high rate of evaporation, because of which you get a good amount of salinity over here. Dead Sea in Israel has 337 ppt of salinity, and Great Salt Lake in USA has 220 ppt of salinity. Okay, so this is also considered a good amount of salinity. All right. Sorry. In case of Don Juan, it is very cold. So colder, denser water, plus whatever inputs it is getting from the land is also making it very cold. Okay. For example, when you consider Lake Assal, I told you it is in Djibouti. This is here. You are in this place now. Can you see this part? This over here, Ethiopia, Djibouti. Huh? So this is closer to the equator and a very high rate of evaporation. Very, very high rate of evaporation. Okay. So the higher the rate of evaporation, greater the salinity, right? And there are no, how do you say, no influx of any rivers or anything of that sort. See, if there is a river coming in and, pouring into the water or pouring into the lake or the pond, then clearly the salinity levels will be lower. Okay. But now you're saying, sorry, 1 minute. Okay, here we are. So we are saying that Lake Assal has a high salinity because clearly high rate of evaporation and hot temperatures. Temperatures around it are very hot. Okay. Dead Sea, once again, it is both. It lies in a rift, it lies in a fault, it lies in a transform fault. So clearly all that upwelling of magma and surrounded by the magmatic material, that is what is making it, the minerals that are poured into it. And also once again, because high temperatures, greater rate of evaporation. Okay. Great Salt Lake also has the same problem. Great Salt Lake is somewhere over here. Okay. You're looking at the mid region over here. So clearly, once again, very, very high rate of evaporation. Great Salt Lake even looks like it has two colors. It is a great fun thing to see. If I show you, it is going to, See, very good picture of the Great Salt Lake. Can you make out two proper colors over here? Huh? This is a causeway that runs between the lake. The causeway is it's a small kind of a road that you build in the middle of a water body usually, or around the water body, so that you can travel through the water body. Okay, so they have a rail running through here because it's a huge body, right? So they have a small railway line running through here. So this causeway, and this causeway will clearly separate this into two parts. Can you see? One is a slightly pinkish colored water, the other is slightly greenish bluish colored water. The reason why this water, and this applies to our lake here in India, Lonar Lake, right? The one that is formed because of the meteorite, the impact of the meteorite. So even Lonar Lake shows you slightly pinkish colored water, right? It is because of the bacteria or the algae that live inside this. So the temperature of the water dictates what kind of algae can live inside it, okay? And because the temperature varies, hence the algae varies, and hence the color of the water varies, okay? So even this has a different temperature because based on which side it is attached to or not attached to. So because of that, you can clearly see that temperature on one side remains a little higher than the other, and a different kind of algae survives there, hence a different colored water appears there. Similar situation for the Lonar Lake also, because what happens is that first of all, Lonar Lake was formed because of that impact of the meteorite. Okay, so when the meteorite came in, all that volcanic material that usually, because essentially it is rocks, right? Whether you talk of lava or you talk of volcanoes or anything, it is essentially rock. So you're saying that all that material was very similar to a volcano. The meteorite material was similar to a volcano, and that developed that decided the kind of minerals that will stay in the water. Okay, and secondly, it's an inland lake. Lonar Lake is an inland lake. When the temperatures rise, the bacteria changes. The temperature of the water rises. What kind of bacteria lives over there or algae lives over there, this is decided by the temperature, and based on what bacteria lives there, that water looks different to you. It either looks a little pinkish or sometimes a little greenish. So that is Lonar Lake. है ना, लोनार लेक का पानी आजकल कैसा दिखता है? पिंक ही दिखता है मेरे हिसाब से. आई एम प्रीटी श्योर इट लुक्स, अच्छा ये तो कुछ अलग ग्रीनिश दिख रहा है. नहीं नहीं, पिंक दिखता है. आई एम प्रीटी श्योर इट लुक्स पिंक. आई डोंट नो हाउ इट्स लुकिंग ग्रीन ओवर देयर. Maybe because summers में अलग लगता है, winters में अलग लगता है. But in the summers, it will look, in winters, it will look pinkish. Oh, so that was 1 year in which it was looking pinkish. Otherwise, it looks slightly green. Okay, okay. But it is usually the algae that decides what kind of water, what kind of color the water is going to have. Because the algae will live over there. It is the color of the algae, basically. Okay, people? Bacteria, it's a kind of a bacteria that's living in there. Okay. All right, no problem. Here we are. So we are saying that, so depending on where this location is and whatever particular, usually this is I'll explain to you what affects the salinity over here. Salinity will basically depend on either evaporation and precipitation. Okay, these are the two things. If there is a high amount of precipitation, then clearly you're getting enough fresh water and the salinity levels will be lower. Okay, if the rate of evaporation is higher, then clearly the salt formation will be greater, water content will be lesser, and clearly the salinity will be higher. Okay, okay. The salinity is influenced by the fresh water flow in coastal regions and freeze and thaw in polar regions. This is also an important thing. Usually what happens is, look at the Black Sea, okay? Multiple, rivers come in and, they'll just drop inside the lake, okay? That is where they end. The influx of the Black Sea will receive influx from multiple rivers, and all those rivers are bringing in fresh water. So all that fresh water is added to the lake, okay, to the Black Sea, not the lake, to the Black Sea. So obviously the salinity of Black Sea will remain a little lower, okay. Same thing over here also. We will notice a very similar situation over here. You have the Bay of Bengal and the Arabian Sea, okay. Now, clearly, both remain pretty much at the same latitudes. Okay, so ideally, they should receive the same amount of insolation, and the rate of evaporation is also not very different on both sides of India, right? On either side of the peninsula, it is not like the rate of evaporation is a little lower or lesser or more or anything of the sort. Okay, because it is at the same latitude. Both lie at the same latitude. The problem is, rather the condition here is situation changes drastically because you get a lot of influx from the rivers over here. You know, I see the Bay of Bengal, they'll receive the Ganga, Brahmaputra on one side, and then they will receive the Mahanadi, Godavari, Krishna, Kaveri. You know, all of this is received over here, right? These are major rivers, huge volumes of water, which are brought out into the Bay of Bengal. Okay, the Arabian Sea, on the other hand, receives very short and swift rivers. Okay, and clearly you have, and it has to still deal with the temperature, right? The evaporation rate is just as high, and clearly not a huge amount of influx of fresh water coming in. So the salinity of the Arabian Sea will remain ever high as opposed to the Bay of Bengal. Okay, Bay of Bengal usually has a lesser salinity because of the influx from fresh rivers, fresh water from rivers. Okay, okay. All right, then this thing, and also if you're in a polar region and there is the freeze and thaw, when in summers the ice thaws and melts, because of which all that fresh water is released into the ponds or whatever water bodies are available. Okay, at that time clearly the salinity will be a little higher. Okay, lesser. And clearly when the water freezes up, then there is less amount of water. The water is already denser. The salinity will feel like it is a bit higher. Okay, so that freeze and thaw will also happen. Wind blows and transfers water to other regions. Once again, onshore, offshore winds will again decide what the salinity of the water is going to be. If warm waters are blown into a region, obviously the salinity will be higher. Okay, warm waters will usually mean higher salinity. Temperature means higher salinity. Okay, and ocean currents also transfer hot and cold water. If you have a warm ocean current, then clearly the salinity will be raised. And if you have a cold ocean current flowing through near that water body, then clearly the salinity will drop. Okay. Now you have the distribution of salinity. Okay, let's see what the distribution of salinity says. There is a horizontal distribution of salinity, and a vertical distribution of salinity. Okay, so now the horizontal distribution you're saying, it is in the, one second. Normal open ocean, if you're considering a normal open ocean, then the salinity range should be anywhere between 33 to 37 ppt. Okay, that should be the salinity range. And salinity is usually more for landlocked seas, especially in the lower latitudes. Okay, because if they are landlocked, they're surrounded by land, then obviously they are going to inherit the temperature of the land. Okay, they are going to be affected by the temperature of the land. And what can you say about the temperature of the land in lower latitudes? It will be higher. So obviously the temperature of this water body is also going to be higher, and the salinity will also be higher. Okay. The maximum salinity is recorded between 20 to 30 degrees latitudes. Okay, you're saying that normally between 20 to 30 degrees north, you will see that the maximum amount of salinity is found. Okay, lowest salinity usually recorded in polar, subpolar, and equatorial regions. Okay, now these are polar opposites of each other. Polar, subpolar are really high, really cold, and equatorial regions generally have pretty high temperatures, right? Anywhere between 27, 28 degrees Celsius is the temperature over there. So why do these have the same amount of salinity? How do these both have lower salinity? Because polar regions will have lower salinity on account of low temperatures, and equatorial regions have a huge amount of rainfall every day. It rains like this every day over there. Okay, every day between 4 to 6 or 3 to 5, it starts raining like this. It pours every day. Okay, 25 out of 30 days, it's going to rain at the equatorial regions, because constantly air is being, that convection currents are being set up. And air is constantly being pushed upward, warm air. It goes, expands, cools down, condenses, forms clouds, and rains. Okay, precipitation. We have precipitation. So that happens in the equatorial region. And because of that constant precipitation, usually the salinity levels are lower in the equatorial regions. Okay, as they are lower in the polar or subpolar regions as well. Okay, Atlantic Ocean का salinity थोड़ा ज़्यादा है. Atlantic Ocean is a closed ocean, right? ऊपर से you have the Sargasso Sea in the middle. That is another kissa that we'll deal with when we deal with Atlantic Oceans. But Atlantic Ocean has a generally, it is slightly more surrounded by land. It is not very open, as open as the Pacific is. Since Pacific is open, it has a lesser salinity. So Atlantic has a higher salinity. Okay, and Indian Ocean has an average salinity of some 35 ppm. Okay, guys at the back, can you please not talk above me? Thank you. Okay. So this is the horizontal distribution of salinity. Now look at this. This is interesting. North Sea, it lies in higher latitudes. This is the North Sea that I'm talking about. This ocean. Okay. This is the North Sea. है ना? UK के ऊपर वगैरह जो है, that is the North Sea that we are talking about. Okay. So this North Sea lies in higher latitudes and yet has a higher salinity because saline waters are brought to it by the North Atlantic drift. Okay. What you're essentially saying is that there is a warm ocean current over here, Gulf Stream, or uska extension North Atlantic drift. Okay, so this is the Gulf Stream. Ideally, this should be called the Gulf Stream, and this should be called as the North Atlantic drift. Okay, so this North Atlantic drift is a warm ocean current, and this warm ocean current will obviously go, and there is a clear advantage to it that it will keep these ports ice free even in winter. The North European ports ice free even in winter. But of course, it will raise the salinity of the North Sea. Okay, because of higher temperature, the salinity of the North Sea will also be raised. Now, this is clearly at a higher latitude, right? It should not receive enough, insulation. If you do not have enough insulation, then this place should ideally have a lower salinity. But because of the waters of the North Atlantic drift, clearly a large amount of water is brought over there, and because of that, the North Sea will have a higher salinity than usual. Okay, this is one thing that you need to remember. The other is this: the Mediterranean Sea has a higher salinity because of a high rate of evaporation. Look at where the Mediterranean Sea lies. This is the Mediterranean Sea, okay? Surrounded by land on almost all sides and very smaller straits. See, over here you have a small strait. Here you have a small strait. There's the Suez Canal. Then again, there is a very small strait connecting it to the Black Sea. Okay, so you are seeing very narrow straits connected to the other water bodies, but mostly the Mediterranean is surrounded by land on all sides. Okay, and clearly it lies in mid latitudes. When this land becomes really hot, and this land can be really hot. Okay, this land can get really hot. So when the land gets really hot, the rate of evaporation here is also very high, and obviously the salinity will be very high also. Okay, so that is the Mediterranean story. And lastly, you have the Arabian Sea. We already discussed this, right? That the Arabian Sea will have a higher salinity because it has a high rate of evaporation, considering the latitudes it lies in, and less influx of fresh water. And compare that to Bay of Bengal. Bay of Bengal also has a good amount of, obviously, it will also have a high rate of evaporation, but it has a large amount of influx of fresh water from the various rivers that pour into the Bay of Bengal. And that's why the salinity of the Bay of Bengal will be a little lesser, okay, especially when compared to the Arabian Sea. And this one more example is going to be the Black Sea and the Baltic Sea. Okay, let's look at this. This is the Black Sea. This year, Armenia jahan likha hai na, that should ideally be the Black Sea. Okay, this portion of water is the Black Sea. Okay, this is the Baltic. This is the Baltic that we are talking about. So in both these places, you clearly receive a large amount of rivers. Okay, a lot of rivers pour into these water bodies. And because of the fresh water coming from these rivers, obviously the salinity will be a little lesser. Okay, because you get a lot of fresh water. River water does not have enough salts, right? So as long as you keep getting a good amount of river water, fresh water, the salinity levels will obviously be a little lower. Okay, that is salinity for you. And lastly, you have the vertical distribution of salinity. Now understand this: at the surface, salinity is always variable. Okay, because depending on if you are at the surface, the salinity will be, now this can depend on multiple conditions. If the sea is enclosed or not enclosed, if it's an open sea or an enclosed sea, at what latitude the sea lies, do you have fresh influx from river waters or not? So multiple conditions can vary. And because of that, the salinity can be variable. Okay, like Red Sea will have a higher salinity, Mediterranean slightly lower, and Arabian Sea a little lesser, and so on and so forth. Okay, so we are saying it changes from place to place. But at the depth, the salinity is more or less fixed. Okay, and then there is a very distinct zone called as halocline where the salinity changes rapidly with depth. Now, this salinity is going to change in the way that in the equatorial region, the salinity over here. Okay, suppose we are talking about the equatorial region. Okay, what can you say about the surface salinity? It will obviously be less. The surface salinity is going to be less. Okay. Now here, the salinity will go on increasing. The salinity increases with depth. Okay. By the time you reach the depth, the salinity will clearly increase. Okay. What happens in the tropical regions? What can you say about the tropical regions? Suppose now we are talking about the tropical regions. Okay. Now you are talking about the tropics. And what can you say about the surface salinity? It will clearly be a little high, okay, because of high rate of evaporation, enclosed seas, higher insolation received, higher temperatures around the land. So because of that, the surface salinity will always be a little high, okay. What happens to the salinity when it decreases? The salinity decreases. The salinity will go on becoming lesser and lesser as in how you reach the depth, okay. Got it? So this is how it works. So you say that the salinity increases, and also you have to remember that the colder the water gets, the denser it gets, and clearly the salinity also decreases. People at the back, you can either come and sit here and stop talking, or you can leave the classroom. Do one of these two things. And I think this is the second time I am telling you this since the lecture started, isn't it? यार ये ना ऐसे बुत बन जाते हैं ना Here we are again. So we are discussing that the less saline water always tends to lie above the more saline water. Okay. So always, because it is denser, na, saline water is always denser. So more the density, more the salinity, and clearly that's how the arrangement will go. Okay. So that will usually lead to stratification by salinity. So salinity is always, it always makes the water a little stratified. Okay. वो थोड़ा सा ऐसे layers में हो जाता है. You can clearly see the layers there. All right. That is salinity. Okay, good. Now what we'll do is we'll let the ocean currents be. And ये बताइए मुझे. A wide continental shelf does not facilitate the formation or occurrence of natural ports, major fishing grounds, offshore oil fields, or trenches. Does not, meaning what is not suitable on wide continental shelves. बोलिए क्या मिलेगा हमको वाइड कॉन्टिनेंटल शेल्फ पे? व्हाट कैन यू पॉसिबली नॉट फाइंड? What will it not facilitate? What is not conducive for a wide continental shelf? Natural ports. Can natural ports be on wide continental shelves? What is the one disadvantage with the wide continental shelf? If you have a wide continental shelf, then clearly that means that the height of the tides is increased. Also, it means that they are shallow places. Can large ships come in shallow places? No. You will clearly, they can only come in and leave during the high tides when the water levels are clearly raised. Okay. So natural ports are usually those where the water level is naturally, the depth of the water is naturally more. Okay. These are clearly not those places where you can develop natural ports. Okay. So natural ports is a no-no. Major fishing grounds. Can wide continental shelves facilitate major fishing grounds? Do we have major fishing grounds on wide continental shelves? Yes. Sunda shelves, Grand Banks, Dogger Bank. You will have a great one. The Pacific, Northwest Pacific, the Japan-China shelf. You're clearly saying that the more the wider the continental shelf, it means the shallower it is usually. The more shallow it is. And if the continental shelf is shallow, then clearly sunlight can penetrate. What happens when sunlight can penetrate that water? Planktons can grow. छोटे छोटे plants होते हैं, planktons, those can grow. As long as the planktons can grow, smaller fish will come to eat these little planktons. Okay. And if the smaller fish come, can the large fish be way behind? No, they'll also follow the smaller fish, right? So clearly we are saying that major fishing grounds is a yes, a total yes as far as continental shelves are concerned. Okay. Can offshore oil fields be formed on? No, they cannot be formed. Fatma, I'm talking to Fatma. Shouldn't major fishing grounds be on wide continental shelves? They should be, no? Because it facilitates the growth of fish, clearly. The growth of plankton and followed by the abundance of fish. Offshore oil fields, can they be on wide continental shelves? Yes, yes, yes. Because that means more and more material is deposited over there. Okay. More the amount of deposits, more the amounts of sediments, clearly the formation of sedimentary rocks. As long as sedimentary rocks are formed with what do you say, remains, they will result in offshore oil fields, right? That makes sense, है ना? वही से हम natural gas and petroleum and सब कुछ derive करेंगे. So offshore oil fields can develop on wide continental shelves. And trenches, do trenches form on wide continental shelves? No. So अच्छा नहीं, ये तो उल्टा बोल रहे हैं. वो बोल रहे हैं कि wide continental shelf does not facilitate the formation or occurrence of these two. तो हम 1 and 4 should be our answer. Natural ports and trenches are not developed on wide continental shelves. Do we have a 1 and 4? Yes, we do have a 1 and 4. Okay. Okay. Good. करंट्स हमने नहीं किए तो मैं अभी नहीं करवा रही हूँ आपको. टाइड्स भी नहीं किए, ये बताइए. A flat top sea mount is called geo बुलाते हैं. Very good. A flat top sea mount is famously called as a geo. Okay. So we say if this is the water level and you can see a volcanic island above it, we call it a volcanic island. Okay. if you can see one below it, this we called as a seamount. Okay, this is what we call a seamount. And if we see this structure below it, then we call that as a geo. Okay, that is what you're saying. A flat top seamount is usually called as a geo. Okay, what is an atoll? The circular land, with lagoon in the middle. You'll have a lagoon in the middle, right? Corals की वजह से बनने वाला, coral reefs की वजह से बनता है. Very correct. Gyre, we have not covered a gyre yet. What is a trench? Where do you usually find trenches? Oceans, but where? At the slope, at the continental shelf, at the basin. Where volcanic eruptions happen. What is that zone called ideally? Where one plate goes below the other plate? A subduction zone or a Vadati-Benioff zone. Okay, so yes, trenches are very good. Trenches are found in subduction zones. Okay, so if this one plate goes below the other, then this V-shaped structure that is formed over there is usually where a trench is formed. Okay, you can see them at the basis of continental slopes or even on deep sea plains. Okay, trenches and canyons are formed over there. All right. Next one. Black Sea and Baltic Sea have less salinity because of influx of fresh river water, and Mediterranean Sea has a higher salinity because of high rate of evaporation. Which of these two statements are correct, or are they not correct, or is one correct and the other not? Baltic and Black Sea have less salinity because of the influx of fresh river water, and Mediterranean Sea has a higher salinity because of high rate of evaporation. Both are correct? Very good. Both are correct. Okay, we say Black Sea and Baltic Sea definitely have a less salinity because you get enough fresh water from the rivers, and Mediterranean Sea will have a higher salinity because of high rate of evaporation. It is surrounded by land on all sides, and the place gets really, really hot in summers. बारिश भी नहीं आती है वहाँ पे तो clearly this is going to be a little hot, and वहाँ पे high rate of evaporation की वजह से उसका salinity high होगा. So we say both statements are correct. Okay. Do you want to change lectures? No, I'm seriously asking you because या ब्रेक लेना है, आप डिसाइड कीजिए आपको क्या करना है. ये देखिए, कंसीडर द फॉलोइंग स्टेटमेंट्स विद रेफरेंस टू सी वेव्स दिखा है आपको. Good. The height of the waves is determined by the wind speed, wind duration, and fetch. The energy of the wave is proportional to the square of its height, and waves retain most of their energy as they travel across deep ocean. This came from the left field. आपकी NCERT की बुक में कहीं भी इसका रेफरेंस नहीं है. This is a proper CSAT question. ये सिविल सर्विसेज के प्रिलिमिनरीज में पूछा जाने वाला क्वेश्चन है. अनफॉर्चुनेटली दिस इज नॉट समथिंग दैट यूजुअली यू पीपल शुड हैव, बट देन आया है तो आया है बिकॉज ये हमने कभी तो स्कूल में पढ़ा था. वी हैड रेड दिस समटाइम वे बैक इन स्कूल, सो दे आर बैंकिंग ऑन योर मेमोरी फ्रॉम दैट टाइम. ओके, सो टेल मी, height of waves is determined by wind speed, wind duration, and fetch. Yes, these are the three main things that the height of waves depends on. Usually, the wind is the driving force behind the waves. So the wind speed has to be decided, the wind duration for how much time the wind is driving those waves. And lastly, the fetch, meaning for how much uninterrupted distance can the wind blow. Okay, the wind push the water. That is the fetch. So yes, all these three things are correct. Okay, the wind speed, the height of the waves does depend on that. Additionally, it also depends upon the depth of the ocean, because lesser the depth of the ocean, greater the height of the waves. Okay, so you will see that the sea waves are always a little milder or of lesser height when they are deep in the ocean. But as and how they reach the shores, the height will rise. You know that, right? We have surfing and Tsunami is also coming in. Same reason, or same logic everywhere. Okay. Energy of the wave is proportional to the square of its height. Yes. 100 times yes. It is exactly the same. The energy of the wave is proportional to the square of its height. Okay. Whatever the wave height is, uska square karo, usse proportional ho jata hai. And waves retain most of their energy as they travel deep across. Yes, they tend to lose very little energy as they travel across the deep ocean. You would, because basically the, how do you say, the way they lose energy, they keep making it up. For whatever energy they're losing, they keep making it up. So they will usually retain very little amount of energy is lost when they are moving towards the deep ocean. Okay, that is usually there. So we'll go with all three statements are correct, ideally. Now, ocean currents I have not done with you, so we'll not do those. If I find any questions of tides, see, you can see clearly, right? Most of these questions are either based on ocean currents or they are based on tides, right? Once again, tide. This is again tide. Once again, an ocean current. Questions on ocean currents, tides, ocean currents. That is all that you keep getting asked about. Ocean currents, tides. This is one last question that we want to do. Which one of the following is known as a zone of sharp salinity change in the vertical section of the ocean? Salinity change, right? What is changing? If the salinity changes, what will that zone be called? Huh? Then what will you call that zone in which the temperature changes? B for Bombay. No, D for Delhi. B for Bombay. A for Ahmedabad. Huh? So, see, अगर आप कह रहे हो कि if there is a sharp salinity change in this ocean, we are saying salinity is changing. Okay, you are saying that at the surface the salinity was something else, surface salinity was something else. Then between this ocean, the salinity has changed very drastically. Okay, this is the zone that we are calling where the salinity either drops or increases very drastically. Okay, that is the place. Now, if you are calling that a thermocline, what will you call the zone in which the temperature changes very rapidly? Temperature is thermo, right? What is salinity? What are salts usually referred to as? Halides, halo, halocline. People, these are words you should be able to identify everywhere. This is very normal. Across sciences, you will have the same word everywhere. So if science refers to salts as halo, halides, or something like that, then even geography is going to refer to that as halo, halides, and something stuff like that. Okay. So halocline is the place where the salinity changes very sharply. Okay. Thermocline is the zone in which the temperature changes very sharply. Okay. Remember, the temperature drops very quickly in a thermocline, right? Photic zone is usually that zone in which the, if say suppose this is the surface of the seawater, then photic zone is the zone until which the sunlight can penetrate into the sea. Okay, that is the photic zone, and that is important because it decides where the photosynthesis will happen. Okay, if there is no sunlight, photosynthesis below the sea surface cannot happen. Okay, so that is why continental shelves are important, because wide continental shelves usually mean a good photic zone because the waters are shallow. Clearly, you will receive sunlight over there. The plankton over there can perform photosynthesis and grow abundantly, behind which fish can come, hence richer fishing grounds. Okay, so that is the photic zone. And pycnocline is usually where the density changes very quickly. Okay, so if density is changing very quickly, density of the water changes very quickly, then that zone is called as pycnocline. Okay, we are not dealing with it, but since it's an option, you need to know about it. बाकी options पता होने चाहिए. You tell me what you When we say that the ocean currents are moving over here, they will also move over here because of the trade winds and the westerlies. These are also the driving forces. It is the planetary winds that are making the currents move. Okay, for example, this north equatorial current being pushed in this direction is also because of the trade winds. The trade winds are pushing it towards the equator, right? And they are also pushing it a little westwards. They are moving it towards a little bit towards the west because the currents are coming from the east. So clearly, which direction will they be pushing it? Towards the west. So it is the planetary winds also that will drive these currents. Okay. All right. And then, of course, there is the gravity. Gravity tends to pull the water down the pipe to create gradient variations that we already studied, right? That it is the gravity. When I said that when water rises, when the water expands and heats up, it rises, the sea level rises, and that creates a gradient. This is at the equator, this is at the poles. Okay, that creates a kind of, itna bada nahi, but it creates a smaller gradient. It is the gravity that is going to make this move, right? It is because it is the gravity that will pull things down. So it is the gravity that usually makes things move and it will pull the water down the pipe to create gradient variations, right? And also Coriolis force. We discussed this already, that it is the Coriolis force that will make the currents turn a little to the right in the northern hemisphere, a little towards the left in the southern hemisphere. Okay, so that is what happens. So in the next lecture, what we will be looking at is the Pacific circulation. We are looking at the Pacific circulation totally together. Okay, that is not such a huge deal. Atlantic के लिए दो करेंगे, एक North Atlantic circulation and the other will be the South Atlantic circulation. Okay, and lastly, we'll do the Indian Ocean circulation. Okay, there is no guarantee that UPSC ever focuses on one certain circulation. They just keep asking you ocean currents. That is one very standard thing. Okay, they just keep asking you, they give you a bunch of currents. They ask you which of these is a warm ocean current, which of these is a cold ocean current, or which ocean they belong to. And sometimes they just want to raise the difficulty level. They'll give you 4 oceans, they'll give you 4 parts of oceans, 4 currents, and they'll say you mix and match. Go, have fun like that. Knock yourself out, yeah. So sometimes they do that, but mostly it is very simple, cold or warm ocean current and which ocean it belongs to. Okay, that's the kind of thing you can expect. Are we good here? And then after that, we'll do tides. Tides are very simple. In tides, we'll cover just what tides are, what are the causes of tides, what are the specific terms associated with it. And please remember, and this is one question they love asking you, that between 2 high tides, how much time elapses? Between 1 high tide and between low tide, how much time elapses? Okay, so that is there. And I always recommend watching a movie for that tides thingy, so that it will never, Dunkirk. Have you guys ever seen Dunkirk? The movie Dunkirk? No, it's a good film. It's based on the Second World War. So you can watch that movie even for, it's a famous event. Aaj dekhenge, haan ji dekhiega. It's a really good film, and it will show you why tides are important. Because for a major part of the movie, you will realize that some few characters in the movie are just stuck on that beach because the ship won't leave. Because the ships cannot leave without the tide. The one ship that they are really banking on cannot leave without the tides coming in. So until the high tides come in, they cannot leave. That will also remind you of why that coast is important, the whole Dunkirk thing. And then, of course, there's a lot of history behind it. So that's a good movie to watch. But anyways, that is one thing that you need to know. Tides will be an important thing. That time is important. Usually, this part is important. Spring tides and neap tides. This is usually what they question you on. And that is that. ये पूछते हैं बाबा आपको highest tides कहाँ मिलते हैं? Where do you find the highest tides in the world? This is one question they ask you. And then sometimes they just sneakily ask you, where do you find the highest tides in India? And you should know it is Kutch. Kutch usually has some 11, 12 meter high tides, and the Khambat has a little lesser tide, and Bay of Bengal even lesser. So ideally, if you want to have a tidal project the way South Korea does, so I don't think I think in some CDS or that question once they had asked you about that Siva Lake project, but I don't think they've ever questioned you on tidal projects before, because India doesn't have any major tidal projects, right? We've been trying that for some time, but we don't have any. So those are the kind of questions you can expect. Is this okay? All right, then we'll do this next time. Thank you very much.